So I'm going to call out the answer so that you can check what you have done. So on that front page, A is -7, B is 11, C is -11, D is 1, E is 8, F is -34. It should be the front. Yep. The ABC. That's because it's the answer. Okay. All right. Yeah, go ahead. All right. So for the next set of A, B, C, D, so you got A is 20, B is 15, C is -9, and D is 3.
What was A?
A is 20.
And C?
It's all up here on the screen.
Okay.
Okay, now one thing that some of you may have been doing wrong, if you got 2 for A, some of you may have been squaring that -3 and getting a -9, but it should be a +9 because -3 times -3 is going to give you a +9. Anytime you square any number, it's going to be positive. Okay, questions on that first part? So on these, Peyton, Vince, you guys were out. All you're doing here is asking f of -2. So you're taking -2, you're plugging it in for your x, just like we were doing on the IXL. So 2 times -2 minus 3. 2 times -2 is -4. -4 minus 3 is -7. So you're just plugging those numbers in for these. Okay, questions? All right, at the bottom, whenever you're filling out this table, you're still just plugging those numbers in. So, like for -2, you do 2 times 5 times -2 minus 3, which is going to give you -13. So you should have -13, -8, -3, 2, 7, and 12. And then you're going to graph the ones that will fit on this. I did not make this answer key. Whoever did was really messy. But I didn't want to redo it just for that. So you should get points whenever you graph them that are on a line. So the type of function that we call that is linear. Right? Or if you just wrote, it looks like a line or something like that, that's fine. Okay, questions there? All right, the second one, actually this teacher just marked it out. Oh, and I should have, that -2 and the -1, I should have just thrown out because we do not know how to do negative exponents. But 2 to the 0 power plus 5 is 6, 2 to the second plus 5 is 7. 2 to the second plus 5 is 9. 2 to the third plus 5 is going to be, let's see, 8, 13. There, you should get 13 for that one. The negative exponents, don't worry about, we're not doing those yet. When you graph these, it's not going to fit really well, but it's going to be more of a curve there. These are what we call exponentials, but you don't necessarily know that name here, so if you just said it was curved, that's okay. Okay, so for everything so far, you're just plugging numbers in. we looked at a few of these here. This one gave you a table. So A is 2, B is 0, C is 4, D I told you not to do. E is 2, F is 8 or 9, or both of them. Make sure you got both of them there. G is 20, and H I told you not to do. Do not do D and do not do H. Okay, remember here, there was a difference between saying f of negative 3. If I say f of negative 3 is my x, and the y that goes with it is 2. But if I say, like here for E, so Peyton, when I say f of x equals 9, that's like saying the y coordinate is 9, right? So we got to look here, f of x equals 9 is, we're looking in that bottom row. And so right here is where x equals 9, f of x equals 9, and then the x that goes with it is 2. So there's a difference between asking it like we see on A through D, and then asking like we see E through H. Okay? And then for the bottom part, A is 9, B is 3, C is 3, and D is 10. Okay, each one of these are different too, because here it doesn't say find f of 15. It says f of x equals 15. So you replace f of x with 15, and then you're going to have an equation that you have to solve. You should, which one? So you would have to add the 7, which is going to give you 21. Yep, divide by 3. 21 divided by 3 is, oh, you're right. The answer key's wrong there. It should be 7. There, I know, I don't know where I got this from. I think I just got it on the internet, but I do not know if they're the most reliable here. So that needs to be fixed, but it's PDF, so I really can't fix it there. It should be 7. Okay. Any questions on the front page? All right, let's look. Let's see. All right, let's look at a couple things here, and I'm going to have to pull up we're going to do together. Come up here in a second. All right, so some of this next page is pretty simple. You're just plugging in numbers, right? So for A, you would just find G and plug in 10. All right, so it's just going to look like this. So for 1A, you would just have G of 10. You're using the G formula, which is negative 3 times x plus 1. So you just replace that x with a 10 plus 1. So you're going to get negative 30 plus 1, which will give you negative 29. So for 1A on that second sheet, you should have 29. Right? So those first ones are really just straightforward. You're just plugging into whichever function it tells you to plug in. Several of you are having questions, though, whenever you got down to E. E says H of A. Okay? So, whenever we plugged in 10, this meant that x equals 10. So I put the 10 where the x was at, right? So it still means the same thing whenever we see the A right here. It means x equals A. And we're going to put an A where the x is at. So the equation is 12 over x, but we are going to put an A where the x is at. So it just replaces the x with an a. You can't divide 12 by a, so you're just going to leave this like it is. Okay, so if you don't have that already, make sure you're putting that down for E. Okay. Let's look at F. Who can tell me what I should do on F? Okay, what do you think, Wade? Why are you squaring it? For F, so F says find x if g of x equals 16. So first of all, we're using g instead of f, so we would not use that equation with the square. And where would I put that 16? Okay, this tells me g of x equals 16, right? G of x equals 16. That's not x equals 16, that's g of x equals 16. So my equation, g of x equals negative 3x plus 1, I'm taking out the g of x, and I'm putting the 16 right here. So it'd be 16 equals negative 3x plus 1. Okay? So Hank, what would I do to solve that? Good. So I'd get 15 equals negative 3x, and then what would I do? Good. I would divide by negative 3. So negative 5 would equal x. Let's look at h, because h is a little bit tricky. We haven't done equations like this. It tells me f of x equals 23. So, Vince, what would I do for this if f of x equals 23? Okay? Which equation are we going to use there? Okay, good. So we got f of x equals x squared plus 7. So if they wanted me to replace the x, it would look like this. They'd say f of 23. That tells me x equals 23, and I plug it in, right? But that is not what we have here. So they're telling me f of x equals 23. So that means I replace this whole side with 23. So I've got 23 equals x squared plus 7. Now, Peyton, what would I do to solve that? Mm-hmm. Mm-hmm. Okay. Mm-mm. So x squared means that you're multiplying something by itself, right? So the reason we're doing this one right now together is because you hadn't seen this before. The opposite of squaring something is taking its square root. Okay? So if I take the square root of this, it's going to get rid of that square just giving me x. But I must also take the square root of the 16. I know you guys have worked on square roots before. What is the square root of 16, Zane? It's 4. Because when I take a square root, it means what number times itself equals this number, right? What's the square root of 25? What's the square root of 81? What's the square root of 2? No. No. There is one, but it's like 1 point blah, 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 blah. So you can't take square root of 2 evenly. So I was just throwing that out there to trick you. The square root of 4? 2. All right. So it's only the numbers that are multiplied by themselves that you can take the square root of without using a calculator, right? It's not quite dividing because you've got like, you're not dividing by a number. You're trying to ask yourself, like, what number times itself would give me this number. So once you figure out what that number is, it's like dividing by that number. But it's not like dividing by set number. All right, one little thing you definitely don't know yet. 4 is not the only number that's the answer here. Because 4 squared definitely gives me 16. There is another number squared that will also give me 16.
It's 8.
8 squared is 64. What? 2 squared is 4. 2 squared is 4. 1 squared is 1. No, there's another number that when I square it, I can get 16. 2 squared is 4. It's not a weird decimal. Jada's got it. -4. Alright. -4 also gives us 16 whenever we square it, right? So, this is something that I'm not going to have you do extensively. Eventually you'll have to know how to do this, but it's going to be later on. But whenever you square it both sides, you do want to put like a plus or minus, because this could be x equals +4 or x equals -4. But that's just sort of like a bonus. Don't worry about that too much right now. Okay. All right, let's look at I. I asks us for g of b plus c. Okay, so g of x, let's look back up here. G of x is -3x plus 1. So when I see g of b plus c, this is telling me that x equals b plus c, and that I need to plug it in right here where that x is at. So it would look like this. G of b plus c would be -3 times b plus c. You should write this down if you haven't already done these. Yeah, that's because nobody's writing anything down there, just staring off into space.
I thought you were showing us. I didn't know you were.
I've said a few times for you right now. Alright, so you could distribute this if you wanted to, -3b minus 3c plus 1, but can you do anything else with it? Can't put b's and c's and 1's together, so you would just leave it like that. So whenever it asks for g of b plus c, you're putting the b plus c where the x is at. And then you want to simplify if you can, but the only thing you can really even do here is just distribute that -3. Yeah, so you would just leave it. This would be your answer. It might be like a bonus question. And we're going to skip J for now. Yes. Oh, yes, you're right. Go ahead and head down there. Maybe look at Charlie. Thank you for reminding me of that, Hank. He has to go for COVID testing. All right. So. Okay. All right. 2 is asking us to do something here. It's telling us f of -1 equals 1. Okay, these are super simple. Okay. It's asking us to translate it into coordinate points. Coordinate points look like this. You got your x coordinate goes here, and your y coordinate goes here. So if I've got f of -1, what's the x coordinate? It is the negative 1. Because, remember, if we're finding f of something, it's telling us x equals negative 1 right there. Okay? The y-coordinate is going to be your f of x, which is 1. It's whatever it's equal to. So for B, whenever I look at that, Easton, what would the coordinates be for h of 2 equals 7? 2, 7. Okay, yes, wait. Yep, what would you get for C? 1, negative 1. Okay, so just your x-coordinate is what's inside the parentheses, the y-coordinate is what it's equal to. Okay, let's go ahead and do D there. Peyton, what would you get for D? Alright, what is the x? What would it be, Passion? It's going to be 3, and then 9 is your y-coordinate. So whatever's inside the parentheses is your x, and the other number. These aren't answer choices. It's a separate question. Oh, down there, we haven't got to that yet. Those are not answer choices either. They're. Okay, so for this, this is especially something that I wanted to go over together because we haven't really looked at graphs yet. We looked at tables on Friday when we were doing that first sheet. We've definitely looked at equations a lot, but we haven't looked at graphs. Okay, so we're going to do number 3 together. Again, make sure you're writing everything down. So if I'm asked to find f of negative 4, okay, that means my x-coordinate is negative 4, and I want to know what the y-coordinate is that goes with it. Okay? So, I'm going to look at this graph. I'm going to go over here to where my x is negative 4. That's right here. And then we'll find the point on the graph that has that coordinate. So, right here is what we're talking about. Well, let me write on that graph right there. But right here is the point that we're talking about. What are the coordinates of that point? Negative 4, 2. Okay? So if I've got the point negative 4, 2, I'm going kind of backwards from what we were just doing with writing the points. What does f of negative 4 equal? 2. Right? Because if the point is negative 4, 2, then f of 4 would equal negative 2. Kind of going backwards from what we were talking about. So 2 would be your answer there. That's for A. Okay? Let's look at B. B says f of 0. So we need to think, we know our x-coordinate is 0. We want to know what that y-coordinate is, and that's going to be whatever f of 0 is going to equal. So if we go, we're looking on the graph where our x-coordinate is 0. That's this point right here. And so Cameron, what is my y-coordinate at that point? It is also 0. So Cameron, f of 0 equals 0. So your answers to these are the y-coordinates. Okay. Let's look at f of 3. So again, that's telling me x equals 3. So Laura, we're going to look for where x equals 3. So x equals 3 right here. We're going to go down to the graph. We're right here at this point. I don't think it's 2. I don't think it's a negative 2 either, because it looks like right here is negative 2. I'm not going to give you one of these on a quiz or a test, because we're going to have to kind of guess right here, right? It's not exactly on the grid lines. It's somewhere between negative 1 and negative 2. So let's say like negative 1.8. You think that looks reasonable? Yeah. So we would say about negative 1.8. That was a guess. Now, I will try not to give you one like that on a quiz or test just because it makes it difficult for grading. But you'll see these sometimes on assignments. And so, like, I would accept pretty much anything between -1 and 2. It looks like it's lower than -1.5. But okay, then it asked me for f of -5. So that means my x-coordinate is -5. So, Ayla, if I look at that graph, I'm looking for the y-coordinate that goes to the point where x equals -5. What is that going to be? Shouldn't be 1. What do you think, Easton?
Is it 0?
It is 0. Because we would be looking at this point right here on the graph. Right there, where your x-coordinate is -5, and that's going to have a y-coordinate of 0. Okay, questions on that? What if let me just give a couple more to see how you're, like, check up on you. What if I asked for f of -2? It didn't ask for it, but what if I said f of -2? What do you think, Peyton? F of -2. Make sure you're looking at -2. X equals -2. Alright, so we need to know how to look for the right point. So x equals -2. Let me see if I can. I wish I could write on it, but it won't let me on PDFs. Let me open it over here. I can write on it if I open it over here. It'll let me write if I put it over here. Let's see. Okay, so let me zoom in a bunch here. Okay, so if I'm looking for f of -2, x equals -2 right here, right? So I'm looking on this graph. I need to look up or down somewhere on this line. Where does x equal -2? So right here, my x-coordinate is -2. What is the y-coordinate that goes with that? 1, 2, 3, 4. So it would be 4. So f of -2 would be 4. Okay. Zane, what would f of 2 be? Oh, I didn't mean to do that. It is -2. And the way that we get that is right here is 2, right? So if we look at our graph, right here is the point we're talking about. That's where we've got an x-coordinate of 2. And the y-coordinate that goes with it, if we go over here to the y-axis, that's at -1, -2, right there. Okay, Marley, what would I get for f of 5? Oh, f of 5. Perfect. So we're looking at this point right here. Right here's where our x equals 5. It's this point. That x-coordinate is 5. We go over here to the y-axis. -1 is the point that goes with it. Does it make sense?
I think this is the graphic part like where I'm supposed to put it. It's
These types of problems you'll have a graph for. Others you might have equations, and if you have equations, just plug in the number. Okay. So these types will have graphs for. I won't ever ask you for like f of -4 without anything. Okay. All right. What about, let me just check. Julian, what about if I ask for f of -1? You might have to estimate here. It might not be a whole number. Look at it a little closer. It is going to be a 0.5, or about. He said 3.5. Should be looking at this point right here, because right here's where our x is -1. And this is 1, 2, up here would be 3, so it's somewhere between 2 and 3. Yeah, 2.8 would be fine. I think that one looks pretty close to 2.5, but I would take a 2.8. But 3.5, that would be up here. That would be above 3. There. Let's see, Caroline, what about if I ask for f of 1? You might have to estimate on this one as well. One is right here on our x-axis, so we're looking at this point right here. Our x-coordinate right there is 1. What would our y-coordinate be? We're on that third page of the worksheet. It's a little higher than -2, so I would say like maybe something like -1.75. This point right here. This one right here is what we're looking. So somewhere. I usually try to keep those off of a test. Not that they're not good to do. I just don't like ones where you have to estimate on a test because it makes a range of values, really. Okay. All right. Now, let's talk about what it's going to look like when we answer E and F. All right. So if f of x equals 2, is that our x-coordinate or our y-coordinate? That's our y-coordinate. So this time we're doing this differently. We're looking on the y-axis right here where this is 2. We have more than one point that has a y-coordinate of 2, right? We've got this point right here. That's something 2. And then we also have this point right here, which is something 2. So sometimes when you have these types of problems, you sometimes get more than one answer. So if I look at this point right here, so right here I've got a y-coordinate of 2. What's the x-coordinate that goes with that one? X-axis is here. Not 4, but -4. Okay? So -4, x equals, let me do that. Can't scroll. Do not smash the sink, though. It didn't hurt anything. All right. You put it in the bottle. That was a good trap there. All right. It's fine in that bottle, I think. You just throw it away. All right. All right. For a little while. All right. Okay. All right. So we would have x equals -4. right here. This one's going to require a little estimation. What do you guys think for that one? We're talking about this point right here. So we know at this point, the y coordinate is 2. So if we're looking for our x coordinate, right, this is 0, right? This is -1. We're somewhere between that, so what would you estimate? -0.8 is a good estimate. Something like -0.7, -0.5, that'd be fine too for estimating. Okay. All right. Let's look at F. Okay. Remember, we're looking at the y-axis 0. So right here, we're looking at the y-axis. This is where this equals 0. So we're looking, here is a point where this equals 0. Here is a point where your y-coordinate is 0. So we've also got 2 for this one. So at this first one, Alyssa, what is our x-coordinate? Not quite. It's not 5. -5. So we'd have x equals -5 for one of our answers. And then Vince over here at this point, what is our x value there? You don't have to estimate on this one. What would our x coordinate be at this point here? Good. So we also have 0 there. Okay. All right, so we are going to go ahead and move on for today. We may or may not do this last page. I have to decide if I want to later. So I'm going to pass out your notes. Sorry about that, Kristen. Okay. All right, so here is our last one. 22-ounce bottle of ketchup costs $2.35. What you're probably wanting to know here in this case is your cost per ounce. So dollars per ounce. So if I want my answer to be dollars per ounce, what goes on top? The cost, the dollars. So $2.35 over 22 ounces. So $2.35 divided by 22 ounces is going to give us 10.1068. So I'm going to just go 11 cents per ounce since we're talking about money here. But although when we're comparing, we might really want to. We're going to see where this would be important to us here in just a moment. Okay, questions? All right. Okay, so here's where we would use what we did in just last 3. And this is something that you can use all the time when you're shopping. Okay? So if you're buying shampoo, most of the time, whenever you go to the shampoo aisle, there are several different options of what size bottle of shampoo you can buy. You can buy a small bottle. You can buy a giant bottle. In general, it's usually cheaper to buy the bigger bottle, right? But it is not always cheaper to buy the bigger bottle. You have to watch out. They trick you sometimes. So to know, you want to find the cost per ounce for each bottle, right? And then you can compare them, and assuming that you don't care what size the shampoo bottle is, and you're going to use the same kind of shampoo for a while, so it doesn't matter whether you got 12 ounces or 20 ounces, you want to buy whichever one's cheapest, right? Unless you guys just have so much money you just don't care. Just pay whatever anybody charges you for anything. But this, I generally try to buy what is cheapest. Especially since in this case, you're talking about the same kind of shampoo, right? It's not like I'm buying the cheap shampoo that I don't like versus the expensive fancy shampoo I like. We're just talking about quantities here, right? So if I want to know the price per ounce here for my 12-ounce bottle, I'm going to take $3.25 and divide it by 12 ounces. Oh, wait. That's 3.25 divided by 12 ounces. All right, so I get 0.27083. I'm going to keep a lot of those decimal places. Keep all of them, actually. 27083, and that 3 keeps repeating. I don't want you to round it because sometimes the difference is out there in the, like, zeros way out far. So, like, if you round this to 27, the other one might also round to 27, but they're not actually the same. So I want you to keep a lot of decimal places whenever you're doing this comparison. If it's just giving me the unit rate, you can round it to 2 decimal places since it's money. But for comparisons, you got to keep the whole decimal. So, Vince, what would I do for the 20-ounce bottle? What would I calculate here? Good. And this is, I should have put dollars per ounce here. And then, so I get 0.23. And that's dollars per ounce. So 23 cents per ounce. Which one is my better buy? The 20-ounce bottle of shampoo. All right. So in this case, and it usually is cheaper to buy the bigger bottle because you're buying in bulk, right? So it's usually cheaper for that to happen. You mean more or less?
I've never seen one like
Is your shampoo more expensive than $4 or less expensive than $4? You're thinking that's expensive? You should look at you should look at buying shampoo at the beauty shop or something. It's like $20 or $30 a bottle. Yeah. So yeah, they do. So it just depends on where you want to spend your money at, but there's definitely cheaper shampoo than this, but there's also way more expensive shampoo than this. So, all right. Okay, now let's look at what we can do to use unit rates for things. Okay. So in this instance, Jan can type 54 words per minute. How many words can she type in an hour? So this is a unit rate that we have here. She can type 54 words per minute. An hour is 60 minutes. So what would we do to figure out how much she can type? We're not going to divide in this case. It's going to be 54 for each minute that she's typing, which is going to be 60. So you're going to multiply in this case. So 54 times 60. They don't teach y'all to type anymore. I can type that fast. I mean, it's pretty fast typing, but I can probably type that fast.
I can type fast, but I can't find the words correct.
I can probably type that fast. I think.
I can type fast.
Yeah. They don't teach y'all to type anymore, though. I need to teach Hunter how to type.
Wait, what grade is Hunter in? No,
Fifth.
He's in what? He's third grade.
Huh? He's fifth grade. Fifth grade.
He started typing like 6th grade.
Some. Not extensively, but some. Yeah, I think they should teach it a basic level of it just because I think you should be able to read cursive. Because all, like, old documents are written in cursive. Yeah. I don't necessarily think they should like go crazy with teaching cursive and like make you write all your assignments in cursive, but I think they should teach it basically.
I feel like the biggest issue is because you have to do that for drawings, right? Like adults, it would be nice if we did know how to do it. Our third grade teacher did do that.
I could read his name, but I couldn't read that girl's name.
All right. Okay. All right. Example 6. Allison makes $12 per hour. Oh, this seems relevant, right? So Allison makes $12 per hour working at the cookout. They got a sign saying they're hiring for $12 per hour for something on their window there. So if she works 17 hours this week, how much money does she earn? What we got to do here, Easton? Multiply $12 per hour times 17 hours. 204. So Allison would make $204 until the government gets a hold of it. Then it wouldn't be $204 anymore. Y'all were in a very low tax bracket with a part-time job, though, so they won't take as much of yours as they take of mine.
More money. Because as busy as it is, I think everybody can pay. Have you had that cookout?
We just went by and got a milkshake. I haven't eaten food there yet. Alright. You always take the inside lane. Especially there. Unless the outside's way shorter than the inside.
We're just waiting until it gets a little bit shorter to the point where we
Okay.
might take some.
Alright, Passion drove 140 miles in 3 hours. If she travels at the same rate, how far could she travel in 8 hours? Alright, everybody hush. Okay. Passion drove 140 miles in 3 hours. If she travels at the same rate, how far could she travel in 8 hours? What you think, Wade? Okay. So if I do 140 miles divided by 3 hours, what's that give you, Wade? 46.6 repeating miles per hour. Okay? Okay, so that's how far she can go in 1 hour. We would multiply it by 8. So we take this number, 46.6 repeating, and multiply it by 8. Whenever you do this in your calculator, you will be wrong if you just do 46.6 times 8. That'll give me 372.8. That's going to be wrong. Okay? So you either need to do it this way. When you did 140 divided by 3, you got this number. You can take that number and just hit times 8. And that will give you 373.3 repeating, which is correct. You haven't rounded off and lost the 0.4 miles that was there, 0.5. Or the other way you can do it if you have a repeating decimal, just type in a bunch of 6s before you hit times 8. That will work also. So we got 373.3 repeating miles. Okay. Questions? All right, you have 2 extra credit options here for you. Okay. This first one is unlimited. It is going to be due October 22nd, or by October 22nd. You can turn it in to me anytime you find it. So, you are going to look for, so typically whenever you're buying things, it is cheaper to buy in bulk or to buy the store brand, right? So if you go to Walmart, if you buy Great Value cereal, it's cheaper than buying the real stuff, right? If you go buy Great Value green beans, they're cheaper than buying the Green Giant green beans, right? Or if you're at Food Line, it's just Food Line brand, isn't it? If you're at Ingles, it's the Laura Lynn, you know, the off-brand that they have for the store. So, you have 2 options. You can either find a product in the store where buying in bulk does not save you money. So you got the 8-ounce jar of Peter Pan peanut butter is actually cheaper per ounce than buying the 24-ounce jar of Peter Pan peanut butter. Now, that doesn't happen a lot, but it happens sometimes. One thing I can tell you, I do online pickup for my groceries a lot here lately, but even if you're doing online pickup, you can still find this. You don't have to go buy the stuff to see. But at Ingles, the eggs used to be like this a lot. Buying 12 eggs was cheaper than buying 18 eggs. Like 12 eggs might cost $1, 18 eggs might cost $1.75 or $1.80, which is actually more per egg than if you just bought the 12 dozen of eggs there. So you can. It has to be the same product. So it can't be like the Great Value, small jar of Great Value peanut butter is cheaper than the big jar of Peter Pan. It's got to be the same product if you're doing this, okay? So it's got to be the 6 rolls of toilet paper is actually cheaper than the 12 rolls of toilet paper of the same brand, all right? So that's one thing you can look for. The other thing you can look for is a product where the store brand is actually more expensive than the national brand. This doesn't happen that often unless they're having a sale on something. So if the Peter Pan peanut butter is on sale, it might actually be cheaper than the Great Value peanut butter. Usually it's not, but it might be if it's on sale. So sales is usually where you see that happen. It has to be the same. It has to be the unit price has to be cheaper, not like here's a 24-ounce jar of peanut butter and it's cheaper than this 32-ounce jar of peanut butter. It's got to be the same. It's got to be the unit price. It's got to be cheaper.
Exact same thing.
And it's got to be, it's got to be the same. In this case, it won't be the same brand, but it'll be the same product. So they both got to be peanut butter. Yeah. Okay. All right. So each one of these that you can find is worth 2 points on your lowest test grade, and you can do this unlimited amount of times. You don't have to purchase them. You can just take a picture of the prices of each one and make sure you have the ounces there with it. You can also do this with online products, but they have to be coming from the same store. So you can search for things online. You can go to Walmart.com and search for peanut butter, and you can just take pictures of that. But it has to be coming from the same store. You can't find a price for Walmart and then check a price for Amazon because that's different than what I'm looking for. So it has to be coming from the same store if that's the case. But they're due at least by the 22nd because that's the last day of this 9 weeks. So I have to have them by then or I can't add any extra to this. I give this every year. I hardly ever have any kids do it.
I'll do it.
It's unlimited. If you can walk, it might take you a couple hours to walk through Walmart and find a bunch of them, but if you can find a bunch of them, it will add 2 points for each one to your test. So if you found 20, that'd be 40 points added to a test.
Big bet.
You can, whenever you have these, you need to, whenever you have these, you need to email me the pictures with the price tags, and then your work for it. And you can do this along the way. So if you find eggs today, you could send me the picture of the eggs. And if you find peanut butter tomorrow, it can be clothing, but clothing typically is not sold in bulk. So it might work with socks or underwear or something they sell in packages, but not like shirts because they're usually sold individually. Yeah. All right, quiet. Do not pack up. Quiet. I got to explain one more thing. Go ahead. I would give you 100. But I'm telling you, kids don't even ever turn this in. I'm always sad that they don't. You get 100 added to your lowest test grade. So if you have a 25 for your lowest test grade, you will change it to 125. For real. I don't even ever have kids turn one in. So I would love it if you came up with 50 of these.
Will that bump our grade?
Huh?
Will that bump our grade?
Yeah.
Okay, big bet.
Okay. All right, here's another bonus problem for you. Okay? This is a real life scenario for you because several years ago, my husband had to drive to Winston every day for work, and I only had to drive just from State Road to here, so I didn't have to drive that far. And so he had a Ram truck, and it got probably about 17 miles a gallon. And I drove a Toyota Corolla that got, I guess, 31 here, at somewhere around there. Right? It got good gas mileage. But he was driving his truck. He was driving his truck every day to Winston. And I was driving the car to school. So, he did not want to quit driving the truck, and he really did not want me to drive his truck. But he had to drive 54 miles to work or somewhere around there. I didn't actually Google it to figure out exactly. This is an estimate here. He had to drive all the way to Winston for work, so it was like 50 miles. I only had like 7 miles.
That's a nice car.
So, I proposed that we switch cars. He did not like that. So then I sat down and I figured up how much money it would save us in a year if we just switched cars.
Did he finally switch it?
Oh yeah. Whenever he saw how much money that was, we switched cars. He still drove the truck on the weekends, but he drove the car to work every day. And we did that for many years before we he works in Yadkinville now. He doesn't have to go as far. My van doesn't really get much better gas mileage than his truck. Yeah. I couldn't. When I had that second kid and we had 2 car seats in the back seat, we had to get something bigger. We didn't have to, but I wanted to get something bigger. So, this right here is worth 10 on a test, and it must have work with it. Okay, you must have work where you showed what you did with it. Okay? So it's worth 10 on a test. I'll put the same due date on that as the other. Yeah. Now this will take you a little while because we're talking about the whole year. I don't work all year long, but I do usually in the summers go somewhere every day. So just pretend like it's all year long.
Has more miles.
It gets way worse gas mileage. So
And if you flip, it would just make it a little bit more better.
because he's driving the car that gets good gas mileage, the long distance.
Okay.
No, he has a Colorado now.
I can't stand the van in Colorado.
They're so short, they're about useless. But all right, so
Yeah, you can sign this. Another sign this.
all right, so I want you to do. There is a part in the back to this. I want you to do the odd problems on this. Okay, odds only. So the odds only, you may use a calculator on the whole thing.
Oh, what's these problems? Be freaking green.
Do you have to do that odd something?
You do not have to do the odd.
Right. I did the first
Odd
one.
problems, you do not have to do the I accept.